All right, welcome everyone. Thank you for being here this afternoon. I'm Ashleigh Myers. I'm a partner at Pillsbury, Winthrop, Pittman, based here in Austin, and I have the honor of moderating this panel today. So thank you all for being here, and I want to thank our panelists for what I'm sure will be a very lively discussion about nuclear fuel recycling in Texas. But to start it off, I actually want to kick it over to Jenifer, and I want you to just get us down to the brass tacks. Like, tell us why this matters. Why do we care about fuel recycling?
Well, gosh, there's a couple of different reasons why I think we should be caring about nuclear fuel recycling. One of them is it provides an opportunity for fuel supply chain stability. Of course, we can be using plutonium produced in a reactor to help fuel our technologies there. And this, we've been talking more and more about this material being considered a strategic fuel reserve, right? And this only becomes increasingly more important as you think about worlds globally tripling nuclear worldwide with respect to uranium resources there. Another piece of this is the ability to hopefully minimize waste on the back end. Many of the technologies that we've been considering are relatively early stage, and the exact waste that will be produced out of them are not fully defined yet, but we can see a plausible pathway where we anticipate that we would have much less waste coming from a recycled fuel cycle as opposed to a open fuel cycle. And so those are just a couple of key reasons why we think about this significantly, but I can also imagine that others on the panel would have thoughts in additions to that.
Yeah, so when we were getting ready for this panel, you gave an interesting statistic about, with the plan to nuclear energy growth in the United States, what the waste load of that would be. And you said something like, we would need, what is it?
Sure, yeah. Generally the talking point that I've come back to most recently, and this was when I was doing a lecture at Stanford with respect to scaling sustainably, and they've been very interested in understanding more about how nuclear fits into our clean energy mix. And one of the things that I pointed out is right now we generate about 2,000 metric tons of nuclear fuel, use nuclear fuel a year. If you look at tripling or quadrupling nuclear, you realize that you're looking at about 6,000 to 8,000 metric tons of fuel per year. This assumes a conservative estimate. Many reactor designs are considering TRISO, which would have a larger mass burden associated with that. The legal limit on Yucca Mountain was 70,000 metric tons. Of course, we can have a conversation about whether that limit could be expanded. That was a legal limit, not a technical limit. There's a lot to suggest that you could have loaded more material into a mountain. But using that 70,000 metric ton limit, if you're generating about 8,000 metric tons a year, you can pretty quickly see that you're in a scenario where you're filling a repository about less than every decade. And as a consequence of that, we've seen that we've struggled to site one repository nationally in the US. I could imagine a scenario where it could be challenging to site repositories on a decadal basis. And one of the other pieces why I also get very excited with respect to recycling technologies is consistently we see interest from communities with respect to what the possibilities of this technology could bring. The idea that instead of just having material sitting around for some time, that you could actually be recycling and putting this back into it. And so to the degree that there are still people that are on the sidelines, nobody in this room is on the sidelines with respect to nuclear deployment, but there certainly are people out there. And my thesis has been that one of the matters is how do we actually manage the waste better? And I believe that recycling would actually have a much stronger social license associated with nuclear deployment than just the standard geological disposal scenario.
So we're in a room full of really smart people, but I'm going to ask the dumb question, maybe David to you. Can you just tell us what fuel recycling is? What's the current state of the technology? Explain it, at a fifth grade level for us.
All right, so fuel reprocessing is what we used to call it, recycling now. That's been in place since the 1940s when the first came up with separating plutonium from nuclear fuel. So we've on the third generation that we've used. We've implemented full scale. There was the bismuth phosphate process, there's the redox process, and then there was the Purex process. That's the most currently implemented. Our company in the UK implemented a Thorpe process, which was a reduced volume Purex process that came out. And now we have the new pyro processing that's coming up that promises even further volume reductions. I'll submit to you that the current Purex process with enhancements have done a really good job of reducing the waste coming out the backside. And we're talking about, putting a resource to use that's otherwise being thrown away, and the repository issues is a huge driver for it, as well as, are we going to be able to keep up the supply chain for the fuel for all of these new nuclear power plants that we're currently talking about worldwide? So I think that's a huge, huge incentive to go forward this way.
All right, so let's take it away from a technical perspective and shift it maybe more to a regulatory one. So Brooke, this one's for you. As the state environmental regulator, what do you see as the key considerations or impediments to deploying this technology within the state?
Sure. Well, I'm Chairwoman Brooke Paup, the TCEQ. My grandmother would kill me if I did not introduce myself. Let's see. It was interesting that I got put on this panel because nuclear fuel recycling isn't really something TCEQ does, or really monitors, or really has anything to do with. But I can talk to what we do permit with these nuclear sites. We permit water rights. We permit TIPDs, discharge sites. The radioactive materials license is enormously important, along with the Class 3 injection well permit. That one's a permit. Usually, it takes about 18 months to get that Class 3 and the radioactive materials license. It costs about $320,000. It's not insignificant. We don't have any applications for new sites in-house right now, but we have a heck of a lot of applications for amendments to old permits that want to get up and running again. So that's really exciting. I'm an appointee. I work for the governor, and he has made energy and water his top priorities. And I would submit that water and energy, I put water first because I'm a water girl, are the most important issues facing the state, 100%. This Texas miracle lives or dies. It flounders or flourishes if we have water or if we don't have power. You can't have one without the other, and the state doesn't run without either.
So that's an interesting point. And, given your time at the Water Development Board, maybe you can share some of your perspectives on folks who are looking to deploy facilities and looking for water resources, and how do they plan in advance to make sure that that's not an impediment once, they start to try to break ground.
Right. Well, water's a problem in the state of Texas. We don't have enough water. The state water plan was released in 2022, and it has a capital cost of $80 billion. And that means in order to build the water supplies we need to withstand a drought of record, a severe drought, the state would have had to put in about $80 billion to ensure that that infrastructure was built. Think about that, $80 billion. That is an enormous amount of money. When we have data centers and nuclear facilities moving in to the state, we are excited. We are an economic development powerhouse. We want all that energy. We want all that data. But that takes water. It takes a lot of water. So what I always first stress to potential applicants who come to visit me, find that water first. Start talking to your river authorities, start talking to your regional water planning groups. Secure that water with TCEQ. They'll need a water permit. And then work on the rest, because that's going to be the do or die for that project to succeed. I do know that Comanche has a water permit of 20,000 acre-feet per year from TCEQ, and South Texas has one for 37,000 acre-feet from TCEQ. Not insignificant amounts of water, y'all. So we have to plan for it, and we are trying to utilize every single water strategy around to ensure that we do have enough water to sustain all of this economic growth.
Okay, and a shameless plug to call your water lawyer, please.
Yeah.
But on this topic, David, Jenifer, maybe you have perspectives on new and emerging technologies and how that can account for water use or maybe reduced use, or creative solutions to this problem that you see in just the resource intensity that it takes.
Yeah, so one of the things I would say, at least with respect to the chemical processes that are used to enable recycling, right? So basically what makes recycling so powerful is you've only consumed about 5% of the energy value, right, in your nuclear fuel rod. Of course, you have to pull that rod out. You've had fission products that grow in that contaminate the nuclear reaction process, and you basically do a chemical cleanup on this stuff. My background is in aqueous solvent extraction processes that actually, and David could talk about this a lot, I understand that the recycling of water within those types of processes has come a long way with respect to resource utilization and things of that nature. One of the things that I've been looking at considerably is, as much as I love aqueous-based processes, there are dry processes that have a significant improvement with respect to what I call the atom efficiency of the process. Basically, how many atoms do you actually need to drive your chemical separation step? And one of the reasons that I care about this is because every time you put an atom in a chemical facility, in a radioactive chemical facility, you potentially generate radioactive waste from that, right? So to the degree that you can minimize the chemical inputs to your process, you can minimize the radioactive outputs from that process. And so while it's not necessarily always coupled to water in the sense that we basically consider how to minimize the amount of water in there, we're very attentive to minimizing waste, minimizing it from the perspective of just better process improvement, not because we're worried about water rights, but it's something that we've been looking at more seriously. But I don't, yeah.
Yeah, so, going on what you're going, Jenifer, is that, once it gets contaminated, we're really keen about keeping it within the plant, right? Keeping it under control, and that forces us into a complete recycle as much as possible. We're not at zero discharge from a plant at this point, but I think with, the last time we did some real significant work on design for that, I'm betting we can get a lot closer to that nowadays when we went through it, and especially with some of the new technologies that are coming online. Even some of the accidents that have happened throughout the world and radioactive cleanup that have been going on, there's been significant leaps on that, especially on some of the fission products removal, where we're getting down to drinking water standards for liquid discharges. So getting really, really good at it.
Yeah, at TCEQ, we found that the energy sector has been an amazing partner in trying to conserve water. They realize it does take a lot of water, and most of them have closed-loop systems that try to recycle every drop of that water, and that is a really big deal for the state. So thank you for that.
So on that topic, what new or emerging technologies are you most excited about? What do you see coming down the pike?
Oh, yeah. So some of the things that we've been, would you like to take this?
No, go ahead. No, I think this is your area.
So one of the things that when I started looking more seriously at this space was that there were a couple of different reasons why I felt that we had not recycled in the country for decades, right? We did in the 70s, then we stopped when Jimmy Carter decided that we would not do that anymore as a non-proliferation policy standard. And we've ebbed and flowed from president to president, whether it's a policy prerogative or not, but we've never really been able to generate the institutional and countrywide will to go ahead and start recycling again for the commercial sector. The reasons that this has basically happened is, one, people will frequently point to the idea that recycling is too expensive when you compare it to fresh uranium fuel, or the idea that it generates pure plutonium streams, and that's a non-proliferation risk. It seemed to me that when we developed these technologies that David was referring to, in the 40s, we didn't care how much it cost, and in fact, we wanted it to generate pure plutonium. Right. And so we should actually go back to the drawing board with respect to the technologies that we had developed and designed for cost efficiency and designed for basically not pure plutonium streams. And fortunately, there's been a series of emerging technologies that have made this more and more possible. Some of these are chemistries that I could get into that are enabling with this that might bore people to tears, but other pieces of this are digital technologies, right? The idea that we can actually monitor these systems in real time. And this is a huge unlock for a couple of different reasons. When you look at the oil and gas sector, something that's in our backyard here, people monitor their chemical process not because the IAEA is standing over their shoulder telling them that they need to monitor their process. They monitor their process because it's good practice. It makes for good economics. You want to know what your product is. You want to know if your processing facility is breaking down. And so now for the first time, there's actually an incentive, courtesy of emerging technologies, to be actually monitoring your chemical recycling facility, not just because the regulator tells you to, but because it actually will save you money. And this is a big difference in paradigm. Anytime that we've done material accountancy and recycling facilities previously, it's always been with added cost burden and no cost benefit. And so there's a real opportunity for the U.S. to take a stronger leadership position with respect to this, because other countries are doing it, other countries are thinking about it,
Absolutely.
and they're doing it the same way that they've done it in the past. And, you know, Carter stopped recycling because he felt that the U.S. could lead. Many people just did what they wanted to do anyways, and this is actually a new way for the U.S. to lead in this regard.
Well, and some of the new chemical processes don't actually separate the plutonium out.
Precisely.
You know,
Yeah.
and that's a, you know, that way it's not used for, it prevents proliferation, you know, so you can do that. It can still get put into a MOX fuel and then used in a reactor such as a fast reactor. We have many vendors here that are looking at fast reactors right now, as well as a CANDU fleet up in Canada there with our heavy water reactors. You can take this fuel there as well, you know, and then you can actually use the fuel and harness more of it, and you end up reducing the amount of waste that goes to repository. Right now we have every nuclear power plant in this country has a pad stored in dry storage of spent nuclear fuel. It's a huge resource that's not being utilized, that's sitting there for we don't know how long, not until we get a repository. So getting and starting to tap into that resource, once you get a plan up and running, and you'll get it to become more economical. We're using new technologies to make sure it's efficient and you know, and produces a good product at the lowest cost possible.
Yeah. No, it's a great point, David, because one of the reasons why we had to generate pure plutonium streams in the past was because there was so much uncertainty with respect to the product that we were generating. You can imagine that if you don't know exactly what's coming out of your facility, it's much easier to just separate the products completely and then recombine them. But there is now more emergent tech that says, you know, if I know that I can produce a product that, say, is a 70% uranium, 30% plutonium split, and I know that's what I have coming out of my facility, I can actually generate the relevant fabrication processes that enable that. So there's a whole host of reasons to why technologies are enabling in this space.
And the waste disposal technologies can be integrated in this plant now, which right now they're all separate facilities. You could integrate that all in together into one process, so everything comes out, it's in its final disposal form, ready for use, or, you know, into a landfill.
So Jenifer, your comments, you touched on what I think is the foundational question. It's what do we want our waste management strategy to look like, and how do we develop it?
Right.
Who are the key stakeholders, and when, and how do we get this off the ground? And I want to hear from each of you, because I think you all have unique perspectives.
So right now the law of the land is the Nuclear Waste Policy Act. Of course, it says that everything needs to go to Yucca Mountain, and, you know, even though we obviously are not sending material to Yucca Mountain. And we're at a really unique time where frequently one of the challenges that we've had is we have not been able to deploy nuclear as much as we would like, in part because of questions surrounding waste, right? You've got people sitting on the sidelines not willing to really come forward on this. Courtesy of everything that we're seeing with AI and energy demand, now we're basically able to leapfrog that such that we can see nuclear deployment growing and exciting, while we can also be working on the waste question in tandem with that. And we'll actually be able to capture enough interest from people with respect to how we should actually think about waste. You know, we decided to put the material in a deep geologic repository courtesy of decisions and thoughts that were being held in the late 70s and the early 80s, with the assumption, and it was not an unreasonable one, that it would be very easy to dig a hole in the ground and put nuclear fuel in it. Right? On its face, this seemed like something that we would be very well equipped to do in the 70s when we were thinking about this, right? We've seen that this hasn't actually been the easiest decision, and we've also seen that communities, as we've engaged with them, that there is more interest in recycling. And so while there was every technical reason to believe that deep geological disposal should have made sense, I think what we're learning more and more that social license might change the dialogue with respect to that. And another big emerging facet in this is the possibility of transmutation of materials.
Absolutely.
So one of the aspects here is nuclear. We know that nuclear waste sticks around for hundreds of thousands, if not millions of years, depending on how you want to track it and define it. This is one of the biggest reasons why people struggle with embracing the generation of nuclear energy. But it turns out that you can actually shorten the lifetime of material and how long it sticks along through transmutation. And in one of the enabling techs with this has been actually coming out of the fusion industry with neutron generators and particle accelerators and power electronics that makes it potentially more possible to re-examine the possibility of transmutation. And so what I would encourage at this moment is we don't have to make a choice. It doesn't seem like the public is forcing our hand with respect to how we want this to go. We can let communities assess if they are interested in recycling technologies, and we can let transmutation technologies bear out to the point that maybe we end up saying, hey, maybe a separation, transmutation, and partitioning strategy would be what ends up making sense for us, which would limit the nuclear waste challenge from an intergenerational challenge to hopefully an intragenerational one, where it's less than 30 years that you're having to manage the material.
Yeah, by going down this pathway, you'll be able to reduce the long-lived isotopes. You can reuse most of that stuff, what you're generating here. And therefore, your long-term disposal challenge, what do you come out in 10,000 years? Mm-hmm. Regulatory-wise, that's a really long time. But by being able to reuse these materials to its maximum extent, you're going to reduce the amount of time and your challenge for that repository.
Well, I want to get back to the waste issue. I think that's one of the biggest impediments to nuclear energy in the state of Texas. I heard a phrase this session that I'd never heard before, NIMBY. Do y'all know, have you heard NIMBY? I was late to it. I thought it was a word like my son uses. He says 6-7 all the time now, or Sigma, I don't know. But it's not in my backyard. The state of Texas passed legislation a few sessions ago that said we will not accept high-level radioactive waste. We absolutely won't do it. But we will help regulate and dispose of the low-level radioactive waste. And TCEQ is the head of that, and we run a commission or a little advisory council that helps with that. But it is a big deal in the state of Texas. No one wants that waste, but it's a reality, guys. And it's going to continue to be more of a reality as nuclear gets up and running again.
No, I completely agree with this. There's a long track record of nuclear waste siting breaking down at the state level, right? We've seen instances where local communities will be supportive, federal government will be supportive, and then there's a breakdown at the state level with respect to that facility getting sited. And it's actually one of the reasons why I'm excited to be here at Texas Nuclear Week, in a sense that in an ideal world, instead of people waiting for Congress to take action with respect to what should happen with this waste, I think Congress would actually be much more empowered in a way if the states came with them and said, hey, this is what we actually think is an appropriate solution, because we can get people together on a blue ribbon commission, or we can commission a National Academy study, right? But ultimately, it doesn't seem like the idea of a whole bunch of scientists and engineers getting in a room and deciding what's best for the nation has been a recipe for success right now. And so, I think Texas is in a really unique position to lead, considering their leadership in the nuclear space. And hopefully, states more broadly can team up and figure out what an ideal solution looks like.
Well, I would say that Texas rarely waits for Congress to act. And no offense. Or the feds.
No worries, keep going.
Yeah.
No.
So what I was just going to add to that is that we should look at our neighbors up north, up in Canada. They just recently worked with their local, the tribes and communities for siting a disposal site. So they're made great strides here over the last few years. And that's a model we ought to take a look at and see if that might be something we could do here in the state of Texas.
Wonderful. We like being innovators and number one at everything.
Right. Well, and we were even talking about this a little bit yesterday, David, the reality that classically when countries have deployed fuel cycles, right, France has their recycling facility, the UK had their recycling facility, the idea that a nation basically has a recycling facility. More and more when I engage with states and companies, right, it's not the idea of, necessarily one state having a recycling facility. You'll see instances where people from multiple states are saying, hey, what about a recycling facility here? And I'm not going to say that this is necessarily representative of the state writ large, But I think that there's an opportunity here for multiple communities to potentially benefit and make that decision for if they want to participate in helping to close the nuclear fuel cycle. And I think it could ultimately become a very different model, and one that we maybe need to think about, considering if we really are thinking about tripling or quadrupling of nuclear. It's hard for me to imagine a scenario that if we're really thinking about recycling or reprocessing the material, that it's going to be one recycling facility that rules them all. It just doesn't add up to me.
So
Yeah.
Brooke, as a state regulator, maybe you have experience on how to bridge this gap between industry's needs and this NIMBYism, right, with the public perception, public trust. I mean, first, make sure you're not taking their water. That's concern number one. But how else do you navigate that?
Well, I think discussions, very candid discussions up front and early are the way to do it. This world feels very divisive lately. I don't know if it feels divisive to y'all, but it feels pretty divisive to me. No one wants to have conversations, realistic, candid conversations. That needs to be done for government and private sector to work together. And I think that Texas has shown that those conversations can be had and we can actually get things done. Nuclear is blooming again in Texas, but there's a lot of moving parts to it. But as long as we're all meeting in the middle and talking about the true realities of what it means to get this industry up and running, I think we'll be okay.
Oh, any
Do you want to weigh in?
I would agree with that with respect to community engagement. You know, I think one of the things too that we're balancing in these very early days, I think, of community engaging with recycling technologies is if we feel like it can be difficult for communities to understand the panoply of nuclear reactor technologies and considerations thereof, right? There's kind of even less of a knowledge base with respect to recycling is. And there's a component of it I could imagine from a community standpoint. You could almost have this sounds too good to be true. And, you know, how do we actually wrap our hands around this? And for every, I'm at Colorado School of Mines. You can imagine that there's only a handful of places in the nations where you have an actinide radiochemistry program where there are people actually working and separating with plutonium and having students in the lab that are, you know, nominally the experts in this field. And I think there's probably an opportunity for force amplification of those knowledge bases so that we can advance the conversation.
We'll add to that, I'm an engineer,
I can tell.
Yeah, Jenifer's a scientist, right? So, but we need to, as a technical organization, we need to be able to communicate this to the public, all right? And we need to get it in a form that they can understand the advantages and disadvantages. So we need communication people to work with our engineers, with our scientists, to actually get the message out in an accurate way where they truly understand the risks associated with it and the advantages for it and, what it means to them. That's an important element that I think in the past we have ignored because we're scientists and engineers, right? And that's what we think, and we think everybody understands what we understand. So I think that's an important piece to get factored into this industry as we go forward.
Yeah, I think that's a wonderful point. Community engagement early, having those, again, honest discussions really, really early and trying to make sure that any disinformation that is flowing out about a project is combated and talked about. I do know that in order to get one of these projects up and running, you have to have the radioactive materials license, and I have not had to issue one yet as my tenure as chairwoman, but I imagine that those public meetings are really, really dramatic, right? Especially with this NIMBY mentality. So making sure that you're communicating and your message is clear early on and getting local buy-in is incredibly important. The public is very powerful in the state of Texas, as they should be. We listen to our citizens.
No, and I think another piece within this, and especially with respect to the nuclear community, for the longest time we approached educational efforts assuming the knowledge deficit model, where people we assume that they knew intrinsically less than us, which, there are aspects of that are potentially true with respect to this. But one of the things that is really important as we go on this communication is trying to figure out a way to listen first. You might be surprised to learn what people really view as challenges or what they know beforehand, and it'll go a long way in advancing the conversation than basically, over-explaining something that they may have already understood greatly.
Yeah, as a manager, of people, one of the things I keep telling myself, shut up and listen.
Yeah.
Well, I think that works in every facet of life. You mean that The Simpsons in Homer's job isn't instructive enough?
It's possible that we might have been helped if there were maybe a couple of different examples of what nuclear could look like.
So Jenifer, you touched on this concept of too good to be true, and one of the things that stood out in our conversations prepping for this panel today is actually, David, something that you were talking about, that it's not just fuel. There are other ways to extract materials that are valuable for other processes. Maybe you can speak to those, because I find it endlessly fascinating.
Well, I kind of alluded to it, but you got medical isotopes that are being used, that can be created from the fuel cycle. You got RTGs, radiothermal generators. They can be made. Yep, we got various companies here in the room that are actually working on RTGs, trying to get up where I live in Washington State. We have cesium and strontium reserves that are fantastic for some, I'll call them nuclear batteries, okay? And, even some of the PU-238 is one that was used on the Cassini probe that's going out to Saturn now. And that was, there's all kinds of various uses for these materials, food irradiation. A lot of this has been done in the past, and by getting this and recycling the materials and utilizing as much as we possibly can, you're going to, again, minimize that waste, and you're going to support the fuel cycle here for the reactors. We tripled the amount of nuclear power we have in this country. Where are we get the uranium from? And then you got to enrich it and to supply it. And where a lot of our new companies are looking at HALEU, just under 20% U-235. That's a lot of work. There's a lot of effort that's been put into that. So I really think it's time looks like it's a real possibility to do this again.
Yeah, no, I'd agree with that. One of the things that evolved before I started looking at this space more seriously was, at one point, the value proposition was on waste minimization and securing uranium supply chains. Of course, there was the Russia invasion in Ukraine. We get many medical radioisotopes and other isotopes from Russia. And as a consequence of that, the value proposition potentially shift not just from the core fuel, but actually from many of the key isotopes that exist in relatively small quantities in the fuel, but actually have a very significant value proposition. And it seems that we're going to be needing to stabilize and secure that supply chain for some time. Right? I don't think that we're going to be buying isotopes from Russia anytime soon. And so as a consequence of this means that recycling is offering a variety of different economic benefits, many of which, when I was framing things, didn't necessarily involve the isotope benefit.
So I want to save a few minutes for audience questions, but I want to give each of you an opportunity to share what's the one key message that you want this audience to leave with? Sorry, that's a big question.
Good questions.
Okay. Since I'm the lawyer and the policy gal and not obviously the scientist and the engineer, I will go first. My mother always told me, buy your own drinks and buy your own flowers. These are words to live by. And she said it way before Miley Cyrus made that song up, I swear. What she meant was, if something means a lot to you, you invest in it personally. You take care of it yourself. And that is what the state of Texas is doing with HB 13 and with SB 7, which funds water infrastructure, and HB 13 is nuclear. The government, the leadership in Texas has seen the need. When you're growing by 1,358 citizens a day, you need that power and you need that water, and they spent the 89th legislative session investing in both.
Well, I guess what I'll say is that this technology exists. And there's new technologies coming up as we speak, to the national labs and to the universities, that we can make ourselves more energy efficient, more energy sufficient, right? With Russia, with the uranium, that supply being, coming to an end, should I say, here in the near future. And we're getting a lot of our uranium right now from Russia. And we need to bring this more in-house. Our supply system is less now because it was cheaper to import it. Yep.
No, I think my main takeaway would be if you're interested in nuclear energy, if you're supportive of nuclear energy, then intrinsically you also need to be supportive of a path forward on the waste and what this waste actually looks like, and what do you want the waste to look like with respect to that. And so if you want a scenario where we're working with a deep geological repository, and you will need one even if you do recycle, I mean, that can be the path forward. The reality is that our nuclear waste and what we do with it is a policy dynamic as of this time. And we can change what that policy actually looks like by having representation and voices there. So I'd encourage you to think about what you want your nuclear future to look like and empower you to take action on that.
All right. Sir, you ready for the first question?
Yes, hi, I'm Clay Montgomery. I'd like to ask you about Oklo. So this is an SMR startup. Yep. Their plan is to use spent fuel, reuse spent fuel. And so could you discuss the feasibility of that in terms of, is it legal? How much material could be available? I think their main motivation is in destroying long-lived actinides, but I think it also has to do with bypassing the bottleneck in HALEU supply. I'd like to get your thoughts on that.
Well, so Oklo is just one fast reactor you could use. All right, they are currently looking at it. It's very feasible to recycle the fuel and use it in their reactors. They're one of the kinds of reactors that will do the work. Is it legal? There's reprocessing facility right now running in South Carolina, okay, in this country. So yes.
Yeah. Yep. Yeah, just to double click on that, right, the core technology that Oklo is basically operating with, and a couple of different companies are thinking about this. EBR-2 at Idaho National Lab operated for several decades, and it was a sodium fast reactor where it not only ran that way, but it was also powered on recycled material, and so they really optimize the use of recycled material, the fuel fab, kind of all these sorts of pieces with respect to its operation. And so technologically, it's eminently doable and demonstrated. And in fact, I was surprised to learn how much Russia also has capability with respect to this. I'm not saying that that's where Oklo is taking their, but there's deep knowledge and experience with respect to Russia and sodium fast reactors there. So the other piece, to the legality of it, David already discussed this a little bit, but one of the things to keep in mind is that there's nothing prohibiting it, but the Nuclear Waste Policy Act says that materials are to go to Yucca Mountain. And one of the challenges that we have is that some people might be hesitant because of the legal obligation to send things to Yucca Mountain. If that path becomes obscured by, okay, well, it stopped on its way to a recycling facility, now is the federal government still on the hook for picking it up? I don't want to say that it's illegal, but sometimes the policy structures that we have in place are not the most facilitatory, if that makes sense.
So if I could ask a follow-up. So is this reuse of spent fuel a potential way to minimize the need for HALEU fuel, since so many of the SMR designs need HALEU fuel?
It could be a potential supplement to that, right? You could imagine plutonium-blended HALEU materials, yes.
Yep. Well, thank you for bringing this up. My name's Garrett Kinsman. We're building liquid nuclear reactors based on a 1950s design to do just this, to make medical isotopes, burn up spent fuel and spent other things, and produce medicines. I don't want to be that guy, but it sounds like to me if making fuel today is really hard, these complex assemblies, we can only burn 5%, and then separating it out poses a challenge. Wouldn't it make sense to go directly to a liquid cycle? We're building aqueous homogeneous reactors. Other people are looking at molten salt reactors. If this country is making a big investment into reprocessing and recycling, do you think the natural course of events over the next century is to go completely liquid cycle?
I could imagine a scenario where you end up on that path with respect to going to completely liquid recycle. I think one of the tensions on the rope that you have is the technical readiness of all of these technologies and their deployment and scale, right? And so it's something that's eminently doable, right? People need to invest in it and get the companies going and all these sorts of things to make it happen, but there's nothing that prevents that from happening.
So we're at time, but real quick, ask your question.
It's a pretty long question, actually. Carl Perez, CEO of Exodus Energy, a nuclear fuel recycling vendor that's actually based in France and in New York, funded by the state of New York, interestingly enough. And the question I was going to ask is whether or not the back-end costs are being included in the analysis around the future of nuclear in Texas, because previously, and what's happening today, is a lot of the spent fuel is going into dry storage because there's no more room in the spent fuel pools.
Absolutely.
And that's a result of DOE's breach of contract. Now, starting 2014, and Vogtle 3 and 4 are units under this new regime, the standard contract, you're not going to get reimbursed for storing that spent fuel in dry storage up until 70 years from the start of operations or 10 years after license expiration. For some of these smaller reactor concepts, it would probably take them 5 years to generate enough revenue just to pay for the cast that will hold the spent fuel. How are you thinking about the back-end cost and ultimately the cost of not recycling for the future of nuclear?
You pose that to Texas. Do you want Texas to respond to that? Or?
Maybe as a whole, because I think the standard contract is not often mentioned. We found ourselves in situations speaking with some really prominent vendors that are hearing about this the first time.
I don't know that any one of us here are in a position to really answer that question. There are several companies here that are looking at that as part of their overall fuel cycle, and they're doing the math. You know, you got Oklo, which was brought up, who is looking at that up in Tennessee, right? You got Curio that's looking at it as well. They've been doing the math, and they're pursuing adding recycling to that fuel cycle. So I'm going to make an assumption that they've done the math and that it works out to their advantage to recycle that fuel and provide those additional products as well as for the final disposal.
All right, so we're at time, and I want to just respect
can talk.
everyone's time. Thank you all for joining us today. This has been a fascinating discussion, and I'm sure you'll be around if folks have additional questions.
I'd like to say that this is the sexiest panel I've ever served on.
Oh, okay. Thank you all.
I don't know how